So just broadly, I'm going to go over the overview of the impacts we would expect to occur in Maryland as climate changes. What potential metrics or measurements we can look at when we're trying to detect this change. What are the measures of resilience that we can move forward with in terms of looking at the watershed health and the stream health, as well as potential needs that we need to continue to look for when we're moving ahead with this. So what's going to happen in Maryland? As a result of a 2008 impact study led by Don Bosch, we know that sea level is going to rise 3 to 4 feet, inundating a number of communities and increasing salinity gradients among a number of streams. We're going to have a 4 to 7 degree temperature increase, which could be greater in urban areas where there's an urban heat island effect, and that could affect our aquatic resources. We'll have a negative 10 to a 20% increase in precipitation, although the trends are really pushing for a greater increase, and I would get rid of that negative and say that we're positively trending in precipitation. Our Septembers are already getting wetter. This year was another record-breaking September, and our Januaries are getting wetter too. So try to think about those wetter Septembers and wetter winters and how that's going to affect dynamics of the aquatic ecosystems is important. We're going to have higher runoff in the spring and lower in the summer. Okay. So drilling down into the watershed area, I said we're going to have more winter storms and drier summers, which means that potentially a lot of runoff in the winter that could affect sediment and transport of nutrients, and less water in the summer, which could mean more competition with ag and our ecosystems. Potentially more flooding. We would have a projected to have an increase in 100-year storms by about 20%. So what we're saying is a 100-year storm right now could be 80-year storm or a 50-year storm. And our 10-year storms, which a lot of people base their aquatic resources, looking at stormwater flows, are going to change and increase by 30%, which means we need to think about how this affects our TMDLs. Okay. So how will this affect our streams? I think the core point is that our streams will appear more urban. All the data shows that climate change is going to mean that more intense storms, more intense runoff. So even in streams that have a lot of riparian cover, will potentially have higher peak discharges and more impacted ecosystems. In the central and western portions of Maryland and other areas as we go west, we'll have potentially a loss of cold water species, as well as flow-sensitive species that respond and are sensitive to high flows as well as low flows. Another important aspect that's not stream-related, but we have a lot of small wetlands and intermittent or ephemeral streams that may not be even mapped in the state that are ultimately going to be lost as we change our rainfall regime. And lastly, we'll potentially have more invasives coming into the system as we have higher temperatures and more CO2, which may allow migration of both more trees and more invasive vegetation, as well as more invasive aquatic species like blue catfish. And so just to sort of step back real quick and distinguish when we're discussing how do we move forward and how do we address climate change, you need to understand that there are the mitigation approaches and the adaptation approaches, and these aren't always independent of each other, but they both are necessary to reduce the impacts of climate change on ecosystems and human systems. So the mitigation approach is what we're really moving forward with a lot with our Greenhouse Gas Reduction Act in terms of 25% reduction of emissions by 2020, but we also know that that's not going to solve the global problem. That's what we're doing in Maryland. So we need to adapt in terms of figuring out what are the strategies to make communities and ecosystems more resilient. So thinking about what are the physical aspects that potentially would change with climate. In our previous meeting, we actually discussed some of these. Bank erosion is very important. As streams get more intense precipitation, they will become more urbanized or channelized potentially, and you'll have less connection with the floodplain, and you'll have a loss of potential habitat. Additionally, a lot of these questions are still being asked in terms of the physical changes. Like, we don't know a lot about what's going to happen with these systems. So that's why I'm suggesting that we sort of continue to look at urban systems as an example of what we could expect to see with climate change. Some of the easy measurements, looking at temperature. For instance, we're looking, Maryland has been looking at, putting temperature probes out in the water in a lot more of their watersheds now for a 3-month period, and looking at how those areas are more or less stressed. So those are potential areas where we could start, using that long-term data to look at, how are these changing? Are they increasing temperatures and loss of cold water species because of natural processes? Or are they impacts between land use and climate change? More important in some of the Western portions is pH and maybe acid neutralizing capacity, just because there's potentially more CO2 in the air, and the way that's processed in aquatic ecosystems is important, as well as how it's processed in the oceans. And lastly, connectivity is one thing we've been sort of thinking about in terms of, we have areas where sea level rise is going to be bringing potentially more salt water in to the tidal fresh systems, but you also have interactions between urbanization and climate change. So you could be squeezing out species that are potentially in that interface, such as the dwarf sedge mussel. Next is sort of thinking about, what do we need to look at when we're trying to figure out what species are vulnerable in the system? And some of this will come out in some of our biotic indices, but other aspects won't. So looking at what traits might be the most important traits in assessing the aquatic ecosystem vulnerability. Looking at species that have limited movement or capability of movement between watersheds or between stream sections or tributaries. Certain salamanders don't have very much movement, and also certain invertebrates such as Scott mentioned mussels, it's difficult for them to travel between tributaries. So those species are particularly susceptible to not only land use changes, but impacts from climate change as we get warmer water temperatures. Again, flow-sensitive species, ones that are really responsive to drought. There are a lot of indicators out there now that show what species are responsive to drying habitat conditions, and how can we use those into a better indicator to look at potential climate indicators in streams. Floodplain and groundwater dependent species, again, we could potentially be losing this groundwater connectivity, as we know areas where we're already stressing water, such as the Eastern Shore, where we're already using a lot of the water for agriculture, irrigation, or areas where we're developing in and there's not enough water available for human use. We're all ultimately drawing down those groundwater-based systems and reducing the flow for the biota. But so it might not be a direct climate impact, but it's one that's indirect, because an increase in temperature potentially results in an increase in water use. Thinking about invertebrates, I think it's important to address the winter and early spring emerging species. There's winter stoneflies that live in streams that, if we get more winter precipitation, then we're potentially going to be scouring those systems out and losing those species. And lastly, another important issue is this threshold change. So we need to look at where are there thresholds between cold water to cool water and to warm water species, and seeing where those areas are most vulnerable to the change based on climate change versus our land use planning efforts. Looking at where comprehensive plans for each municipality can factor into addressing maintaining resilient cold water streams versus streams that we know climate change will ultimately create a more warm water system. And how do we adapt to that? Another one that the groups could start to monitor that would, I think, really contribute to the overall information database of what is climate change doing is looking at some of the phenology of the systems, and looking at how snowmelt's occurring. Just simply saying, okay, snowmelt occurring earlier this year, what are we seeing in the streams? Or looking at, are the trees budding out earlier? Are we changing species within that riparian zone? I think these phenology indicators are really important and can be easy to measure by just going out in the field and observing what's going on. Additionally, if you're a trout fisherman and you're going out, you go out to fish in somewhere in western Maryland or farther out, looking at when those mayfly species are emerging and just sort of documenting those and distributing that to your local groups like Trout Unlimited or a local watershed group would be I think a useful fact. And I know in the bay habitats you have to think about the mismatch between plankton and fish species and how that could be potentially impacted by climate. But in non-tidal systems we have the same potential impact where if we have a mismatch between mayfly emergence and trout populations and trout spawning, or there might be some impacts there that may result in loss of species. So going back to getting outside of the stream and looking at habitat, I think there are some parameters that we could sort of think about in terms of what creates a resilient streamside area or riparian zone. And this is a picture of a very large system, Mississippi and Missouri River system, and it shows you here that during flooding, this system it's out of the channel and into the floodplain. And I think it's really important that we consider cases where we can maintain that connection as much as possible. And again, we get back to the diverse vegetation. We have a diversity of species in that riparian zone. There are predictions that show that as climate change, as temperature increases, as precipitation changes, we're going to lose some of our tree species. So if we lose some of these tree species, then we need to make sure that we have other species within that riparian zone to replace it that are already there, or we could potentially be offsetting the riparian restoration that we're already doing. And in terms of habitat, I think thinking in terms of temperature issues in some of your streams, you're going to need to try to do measure deep pools, measure where the pools are deep and where they provide the most habitat for species that are cool water species. So when the main part of the stream could potentially be warming, you still have those refugia that the species can move into. Again, the bank habitat, such as overhanging vegetation and root wads, is potentially another aspect that will help shade and cool the water. So in terms of the species that would be resilient, I think we don't know if we'll see a lot of these stream beds that are completely dry like this, but I think in the headwater streams, I think we will potentially see more of those. So we need to look at resilient species are those that are drought resistant, or they adapt well to changes in flow. Or should we be looking also at the urban species now and the diversity of suburban and urban species and expect that to be what we should see in the future? So there are a number of really critical habitats in this area that if we want to have a resilient watershed, we should really be thinking about protecting or potentially figuring out how to restore them. We have high elevation systems that they'll be moving upwards as temperature increases. Seeps and springs will be affected by groundwater withdrawals as well as changes in temperatures. We have same with vernal pools that potentially are streamside, while some are not always streamside. So we need to take account of the vernal pools and the habitat they provide in these systems for rare and endangered species. And we need to really think about some of these other aspects like cool water inflows from the groundwater as well as tributary junctions where we need to think about the connectivity of the systems, and our species are once they get pushed up to the headwaters because of climate and because the temperature increases, are they stuck there, or can they potentially migrate down and go back up another tributary that may be more resilient to changes in climate? So I'm just going to briefly go over this, but I think when you're looking at methodology, there are a number of things I think we should consider. First and foremost is to protect the reference sites that we have there, because if we don't have those reference sites, then we won't have anything to look at in terms of what we should be expecting with climate change. I think it's also to sort of think about a lot of it, I think, is coordination and looking at where you can sample along a large corridor within that watershed, so we can sort of start to see the responses. There are studies that have actually, seen the actual movement of predatory invasive bass species, and they've been able to use climate change modeling to look at how that's going to be moving because they monitored along that corridor. So I know there's the stratified random sampling methodology, but there's also some targeted methodology we can use to look at climate change impacts. As always, you should always look at where we can improve our hydrologic or temperature data, whether it be just putting your station next to a USGS gauge or trying to figure out ways to get that data in another method. And some of these other aspects, like timing of hatches, we talked about with phenology, but there might be opportunities to sort of collaborate with other institutions that are do the taxonomy on a daily basis or a regular basis and look at we might be needing to look at the genus, at least the genus, and potentially the species, to see which organisms are more responsive to climate change, rather than just looking at the family level in terms of the invertebrate population. And thinking in terms of a lot of the species will be developing faster potentially, we need to think about looking at the size of these species too, as is done in fish populations. So, based on what I've seen in my conversations, I think there are a number of potential needs if we're going to look at where are the climate change resilient areas going to be, what can we do to address them, and what can we be monitoring to look at this into the future. So one of the big ones is that there needs to be sort of a vernal pool monitoring network for the state, and I think there's been a lot of push for that, but it hasn't really gone anywhere. But I think the fact is that these vernal pool systems and ephemeral systems together are likely to be lost as we increase our temperature and then we increase variability of our precipitation. Another thing is that we could sort of start thinking about what would a climate change network look like on the ground, and what would some climate smart measures be for people to start monitoring, or what are the measures that we should be looking at that would be resilient. And I presented some of these, but I'm sure that there are a number of other ones that people have thought about already. And just as an aside, there are some things that either you as a watershed organization can do, or you as a community group, or you as an individual can do to really foster a better knowledge of climate change, foster a better knowledge of resilience, and to sort of move forward with making sure that we can predict and understand what is going to happen into the future. Obviously, just basic water conservation principles like reusing water and reducing our use. Working potentially with the regulatory agencies to look at where the groundwater recharge areas are, because those are the areas that are going to be important for base flow in your streams. So if we're developing our water recharge areas, and then we expect to have base flow in our streams into the future, there's some conflict of interest there. Generally, we should just coordinate. Coordinate with the groups near you, obviously. And I think that's the great thing about MTAC, as well as coordinate with local universities or consultants to, if you don't have the ability to get the resolution that you want, then there are universities that are actively looking for grants, actively looking for money to do their research. So if you can tag onto one of their grants and get that data, that would be even better. For instance, the species level identification for your invertebrates or your fish. And always promote drought-tolerant native species throughout your community, as well as going out there and advocating for all the things that we're talking about here. And that's it for now. Are there any questions?